Welcome back, everyone. Another exciting video on forms of linear equations. In this video today, I'm not going to start out with another form. We're going to sort of, in a couple slides, introduce the third and final form for this section before the quiz. Instead, I want to introduce a slightly more difficult problem, really just involving one extra step, building on what we've learned so far. So if I'm trying to find the equation of a line in slope-intercept form through 2 points. So previously, I'm asking you for slope-intercept form given a point and a slope. Okay, that's what we did the very first day that we did this material. It was on Thursday, last Thursday. Now I'm giving you 2 points, and I am asking you to do the same thing. So I'm sure people are already getting this in that I need to find the slope first between these 2 points using the formula for slope. No, it does not disappear. And after I do that, only then can I then input that slope and a point into either a point slope or slope intercept to solve for the slope intercept form of the line. So I'm going to do actually both real quick for this first example, and I'll show you. So here we go. Here we have the 2 points, negative 1, 3, and 1, 9. So if I'm trying to solve for the slope, it's m is equal to 9 minus 3, and this is just the order that I chose, over 1 minus a negative 1. So 9 minus 3 is 6. 1 minus a negative 1 is 2. 6 divided 2 is 3, right? Okay, so here we have the slope of 3. So no matter which form I choose, I'm using the slope of 3. So I'm going to show you, like I said, one way and the other. Okay, so the first way is using slope-intercept form. This is the way that I'm going to choose to do the problem or another example, just because I feel like it's the easiest way. Although you can use point slope, and I'm going to note that it doesn't matter which one you choose, you get the same result. So number one, we have slope-intercept. Number two, we have point-slope form. First, I'm going to do slope-intercept. So let me just draw a quick line down the center here. Boom, split up my work. All right, so I'm dealing with, once again, the points, negative 3, negative 1, 3, and 1, 9, and a slope of 3. Now, it doesn't matter which point I choose. I can choose this point, 1, 9, or this point, negative 1, 3. Either point will produce the same result. For both of these instances, I'll use negative 1, 3. Um, just because it's smaller magnitude numbers, you can choose to not work with negatives and use 1, 9. It doesn't matter. But let's go to slope-intercept form. So the point is negative 1, 3. Okay, and then we have a slope is equal to 3, like we found, right? Negative 1, 3. Yep. Okay, so we know that this is the point x, y, and this is the slope 3. We're solving for b. So that's the process here. So I'm going to say my y value is 3, so 3 is equal to a slope of 3, that's m, times negative 1 plus b. So this is 3 is equal to negative 3 plus b. When I multiply 3 and negative 1, add 3 to both sides, and b is 6. Okay. Secondly, or no, we're not done. Sorry. So knowing that b is 6, now I can input my slope that I found, 3, into slope-intercept form, and I know that my y-intercept is 6, so therefore that's my final equation. Now, if I do everything correctly, I should get the same thing down here once I finish this calculation. So once again, I'm using the point negative 1, 3. I'm going to say this is y minus 3 because x1, y1 is negative 1, 3 still. So I'm using the same point over here, and the slope that I did from this side is equal to 3 times x minus a negative 1. Note the double parentheses I'm using for substitution, minus a negative 1. So this simplifies to y minus 3 is equal to 3 times x plus 1. So this is it in point slope form. Now, how do I change this into slope intercept form? Now, I said this to a couple of people today, but I just want to reiterate this. My goal here is to basically end up with y is equal to something, and then whatever I put in red, right, in this red box here on the right-hand side, that ends up being slope intercept form, meaning that if I have a isolation of y. So if I just move everything over to one side, that's not, so y is isolated. So anything that's not y on the left-hand side, I move over to the right-hand side. And combine like terms, I automatically end up with slope-intercept form. So let's see. It doesn't matter which first step you do. You can add 3 to both sides first. I like to perform the distributive property first, just because I think it's easier to see. So that distributive property, 3 times x plus 3 times 1. That's how I got 3x plus 3. 3 times x is 3x. 3 times 1 is 3. Add 3 to both sides, and I get, whoa, lo and behold, oh my gosh, am I ending up with the same results on both sides? I am, and there's a reason why. Y is equal to 3x plus 6. Note I got the same thing over here because it doesn't matter which one you choose. So when you're doing this work for the quiz, when you're doing the in-class work on Wednesday, you can start with point slope form over here, or slope intercept form. It doesn't matter which method you choose. I like slope intercept form method number 1, and I'm going to use that method in the next slide here. So another example. Find the equation in slope intercept form through these points. So once again, first step, solve for the slope. 3 minus 4 over 4 minus a negative 5. So what is that? That's negative 1 on top. In the numerator, denominator, 4 minus the negative 5 is 9. So we have negative 1/9 is my slope, right? Okay, now I am taking, and I'm just going to use 4, 3 arbitrarily. Doesn't matter that I'm choosing that over negative 5, 4. I'm going to put it into um, slope intercept form. So y is equal to mx plus b. I know my y, that's 3, that's this y coordinate up here, is equal to negative 1/9, the slope that I found and calculated, times x, 4, whoops, 4, plus, ooh, that is not looking right at all. We are erasing and erasing. In fact, let me rewrite this then. That's just easier. Okay, so my slope is negative 1/9 times my x value, 4, in the coordinate point, 4, 3, and plus b. Okay, so not everything is going to be super pretty. Yes, so we are going to have to deal with fractions here. So when I multiply negative 1/9 times 4 on my right-hand side, I get negative 4/9 plus b. I add positive 4/9 to both sides, and I get b is equal to 3 plus 4/9. Clearly, I'm not done. I need to convert 3 to being a fraction over 9. So what do? If I multiply 3, and I'll convert this to over 1, by 9 over 9, right? Then I can take that fraction and then use it with a common denominator of 9 to solve for b. So what is that? 9 times 3, 27 over 9, plus 4 over 9, and my final result, 31 over 9. Now, do 31 and 9 have common factors? No, 31 is prime. That would not have a common factor. So my final result, y is equal to the slope that I previously calculated, negative 1/9, right, up here. That's my slope. Negative 1/9 plus, sorry, negative 1/9 x plus 31 over 9. And I just wrote 39 over 9. And I don't know why I just did that. Okay. You guys are going to have my head for messing up twice here. Plus 31 over 9. Right. Okay, so that's my final answer. This is in the form of y equals mx plus b. Once again, an equation where I've given 2 points, and I've solved for the slope, put it into slope-intercept form to solve for the y-intercept, and then generated my answer. Y is equal to negative 1/9 x plus 31 over 9. Clearly, I want you to do one. That's your turn. So try the same. I promise you the calculations won't be quite as difficult involving fractions for this one. Okay. Now, I want to talk about the third type of equation. This is called standard form of a linear equation. Basically, what standard form means is that ax plus by is equal to c, capital A, B, and C here. So this is an important point. A, right, is greater than 0, okay? A and B cannot both be 0. So that means this is not 0 is equal to a constant. And a, b, and c are integers whose greatest common factor is 1. So what does that mean? That means that standard form is fully reduced, meaning that there are no common factors between a, b, and c. Okay? Now, I'm not going to ask you questions on this, but this is an example of, and let me actually do this in black uniform here. Black and racy. Right. This is an example of an equation in standard form. 3x plus 4y is equal to 6. Right. Okay. So clearly, this is A, right? 3, 4 is B, capital B, and 6 is C, right? Now, do 3, 4, and 6 have a greatest common factor other than 1? No, they do not, right? 3 is prime. So there's no way that 3 can have a common factor other than 1 to 4 and 6. If, and just be with me here for a second, if I have 2x plus 4y is equal to 6, so all I did was change the value of A, these A, B, and C do have a common factor whose is not 1, that is greater than 1. And what is that? If you said 2, you are correct. So what can I do to change this into standard form? What I do is that I divide all three of these terms, the x term, the y term, and the constant term here, by that greatest common factor. This GCF, okay, is 2, right? Greatest common factor between 2, 4, and 6 is 2. How do we get the greatest common factor? We list all the factor pairs. That greatest one that represents in all three of the lists is the greatest common factor. I think it's probably pretty easy to see. Everyone's had a lot of practice with this. So what do? If I divide every term by 2, now my equation is in standard form. X plus 2y is equal to 3. Here we have coefficients a, b, and c where their greatest common factor is 1. We don't write this, right? But we know this coefficient is essentially 1. I'm going to erase this because you shouldn't be writing that, but I just want to note that. So an equation in standard form, or examples of equations in standard form, I will box out in green. We have this one down here, x plus 2y is equal to 3. And we have this one up here. 3x plus 4y is equal to 6. Right. Okay, so the skill that I want you to be able to do here is find an equation of a line in slope-intercept form given an equation in standard form. So how do we do that, right? How exactly are we supposed to go about doing that? Same exact thing that I said before in that. We want to isolate for y here, right? If I want to have an equation in slope-intercept form, which is in the form of y equals mx plus b, just to familiarize yourself, I want to have it as y equals something. Whatever I have on this right-hand side, as long as I combine like terms, I'm done, right? There's no need to go on. So how do I do that? Here, we're not just adding or subtracting a constant from both sides like we did from point slope form. We do need to do a little bit more work. So I am starting with the equation 6x minus 3y, and I'm going to rewrite it just for clarity. 3y is equal to 9. So I want to isolate for this y. I want it to be the only thing, right? So how do I do that? The first thing that's being done to this inside of the equation is that I'm adding 6x, right? That's one of the first operations to y. So for that reason, I need to get rid of this 6x or any other term that doesn't contain y here. So how do I do that? I subtract 6x from both sides, subtract 6x from both sides, and my final result, which of course is not final, these add to 0, negative 3y is equal to negative 6x plus 9. Note that I put negative 6x first, right? Because I want to keep the equation as y equals mx plus b, where the x term is first. So what do I do now? I'm not done, right? Because I need to have this y isolated. So what do? I have to divide both sides by negative 3, okay? Divide this side by negative 3, divide this side by negative 3. Now, this left-hand side, clearly this divides to 1. Very easy to do, and I can just literally just write y down here, and I'm good to go. This side is not so easy, and I want to break this up for you. When I divide by negative 3 on this whole right-hand side, two terms, negative 6x and a positive 9, the linear term, negative 6x as it's called, and the constant term, 9. What I'm literally doing is really just dividing both by negative 3. So if I divide a full side of an equation by a constant, right? In this case, it is negative 3, Take care to note that all I'm doing is dividing both terms by -3. So a lot of students get stuck on this step right here, which I'm circling in red. They're like, what am I supposed to do? Is this just a fraction? No. If I have the sum of terms in the numerator, I am free to break up, okay, this into two separate fractions, basically, and divide both by -3. So this is an important sticking point here. Okay, so what is this now? Let me switch back to black ink. Erase, erase, switch black to black. Right. Okay, so what is this term now? This is y is equal to, what's -6 divided by -3? Positive 2, 2x. What is 9 divided by -3? That is a -3, 2x minus 3. Right? Boom, I'm done. Now I have an equation in slope-intercept form that I started from standard form, right? Here's the standard form, 6x minus 3y is equal to 9. These equations are equivalent, but now I know its slope and I know its y-intercept. Okay, let's do another one. 5x plus 4y is equal to 11. Same exact thing. If I subtract 5x from both sides, because I want to isolate for y, I get 4y is equal to negative 5x plus 11. Divide both sides by 4. Divide by 4. Divide by 4. This divides to 1, so I get y is equal to, and then I take care to note that when I divide negative 5x plus 11 by 4, I can really split it up into two separate fractions, negative 5x plus 4 plus 11 over 4. And anytime that I have this x floating in the numerator, I can feel free, and this would be fine to answer it like this, because this actually is a final form. But I just want to note, negative 5x divided by 4, you can then push the x variable, or x over 1 really, off to the side. And the coefficient to x is negative 5/4. So you can term this to be negative 5/4 x. These two fractions are equivalent. Plus 11 over 4. And that is now my final answer. So not as clean, but the slope is negative 5/4. The y-intercept is 11 over 4. So note that not every answer, like this last one, is going to have an integer result, 2x minus 3. I will ask you to work with fractions heavily, and I'm sure you've already noticed that in these sections. So be careful to note that you'll always see fractions. Fractions are your friend. I know I said this the last video. Okay, so I want you to try approximately the same thing. In this next one, convert this equation in standard form to slope-intercept form. And we'll work a little bit more with standard form in the next video, which we'll do on Friday. And everybody remember, test on Tuesday as well too. Test on next Tuesday. Okay, hope everybody enjoyed this video, and I'll see you in class on Wednesday.